Lathering the Science, the Chemical Odyssey of Soap. Page 1, The Dawn of a Chemical Revolution. In the arid landscapes of ancient Babylon around 2800 BC, ingenious alchemists discovered a reaction that would forever change the course of hygiene. When water mixed with alkali from wood ash met animal fats, an unexpected chemical transformation occurred. This process, later identified as saponification, produced the first primitive soap, a substance that not only cleaned but also carried cultural and medicinal significance. Clay tablets from that era reveal meticulous records of these early experiments, marking the beginning of a legacy rooted in both science and necessity. Page 2, The Molecular Ballet of Saponification. At the heart of soap making lies a fascinating chemical dance. Saponification occurs when triglycerides, fats, interact with a strong base, such as sodium or potassium hydroxide. The reaction splits the fats into glycerol and long-chain fatty acid salts, the soap molecules. These molecules boast a dual personality, a hydrophilic, water-loving head, and a hydrophobic, water-repelling tail. This unique structure enables soap to emulsify oils and capture dirt within tiny micelles, effectively transforming grime into a removable film. Imagine each soap molecule as a tiny cleaning agent, orchestrating a microscopic ballet that purifies as it goes. Page 3, From Babylon to Egypt, Early Innovations. While Babylon's early experiments laid the groundwork, ancient Egypt refined the art with purpose and precision. Egyptians, renowned for their advanced understanding of both spirituality and science, used soap-like substances not only for cleansing, but also for religious purification and mummification. They blended animal and vegetable fats with alkaline substances and aromatic herbs, creating mixtures that were as much ritualistic as they were practical. This melding of chemistry with culture underscored the intrinsic value they placed on both physical and spiritual cleanliness. Page 4, Roman Ingenuity in Public Bathing. The Roman Empire took these innovations a step further. In their vibrant communal bathhouses, soap became a symbol of both hygiene and social sophistication. Romans carefully experimented with combinations of tallow, wood ash, and botanical extracts to create soap that was effective, aromatic, and even luxurious. Their public baths were not merely places for cleansing, but centers of civic life, where the science of soap making meshed seamlessly with everyday social rituals. Here, precision in ingredient ratios foreshadowed modern chemical engineering, as even small variations could alter the soap's texture and cleaning power. Page 5, The Scientific Underpinnings, Reaction Kinetics, and Quality Control. Delving deeper into the science, the ratio of fat to alkali is crucial. Too little alkali leaves a residual, greasy fat, while too much renders the soap overly caustic. Early soap makers discovered this balance through rigorous trial and error, a primitive form of quality control. Today, modern analytical methods like gas chromatography and mass spectrometry allow scientists to study these reactions in minute detail. Factors such as fatty acid chain length, saturation, and the critical micelle concentration determine not only the efficacy of the soap but also its texture, lather quality, and overall performance. Page 6, Industrialization, the Mass Production Era. The advent of the Industrial Revolution marked a dramatic shift in soap production. Artisanal methods gave way to mechanized processes, transforming soap from a local craft to a mass-produced commodity. Factories emerged as modern laboratories where chemists engineered soap on an unprecedented scale. Despite the loss of some traditional techniques, industrial methods incorporated precise chemical principles to ensure consistency and efficiency. While these large-scale processes brought soap within reach of millions, they also spurred the development of synthetic detergents, engineered to outperform traditional formulas in certain applications. Page 7, The Resurgence of Artisanal Craftsmanship. In recent decades, there has been a vibrant resurgence in artisanal soap making. Modern craftspeople have embraced the cold process method, a technique that preserves the natural properties of ingredients like olive oil, coconut oil, and rare botanical extracts. This revival is driven not by nostalgia alone, but by a profound appreciation for the chemical artistry behind soap. Artisans now harness modern biochemistry to optimize saponification, ensuring that each bar is not only effective but also gentle on the skin. Their work reflects a harmonious blend of scientific precision and creative expression, offering a counterpoint to mass-produced products. Page 8. Engineering at the molecular level. Cutting-edge research today focuses on tailoring the molecular architecture of soap to address modern challenges. By manipulating the length and saturation of fatty acids, scientists can engineer soap to target specific contaminants more effectively. Innovations such as enzyme-enhanced formulations and bio-inspired surfactants promise products that are biodegradable, hypoallergenic, and optimized for diverse environmental conditions. This level of molecular engineering transforms soap from a simple cleaning agent into a sophisticated tool capable of addressing everything from skin health to environmental sustainability. Page 9. Soap as a cultural and scientific symbol. Beyond its practical applications, soap has evolved into a potent cultural symbol. Throughout history, it has represented transformation, purity, and renewal. In literature and art, soap has often been depicted as a metaphor for the cleansing of both body and soul. This dual significance resonates with the scientific marvel of its creation, where ancient wisdom meets modern chemistry. Whether in the halls of Roman bathhouses or the laboratories of today's research centers, soap embodies the enduring human quest for innovation and improvement. Page 10. The future frontier, innovations on the horizon. Looking ahead, the journey of soap is far from over. Researchers are exploring novel frontiers in green chemistry and nanotechnology, aiming to create soaps that not only clean but also deliver therapeutic benefits. Future formulations might integrate advanced biomaterials designed to interact with skin cells or deliver drugs in a controlled manner. As science continues to unlock the secrets of molecular behavior, the humble bar of soap stands as a testament to the limitless potential of human ingenuity, a symbol of how a simple chemical reaction can catalyze centuries of innovation and cultural evolution.